So, hello friends, back to another research news. Basically, I will describe you various kind of research facts, okay, or news. You know, there are several channels, media that covers the news on politics, calamity, and everything except science. Today, our technology is far more developed. But how we have reached this position? This is because a long time ago, few scientists sacrificed their lives in searching for new theory, new technology. Like Sir Isaac Newton, who have did everything to deduce formula of gravity, laws of motion. We know the contribution of Nikola Tesla in AC current. Today, if there is 1 hour electricity cut down, then you will feel bored, irritated. But this electricity has been discovered late early when Nikola Tesla first analyzed its processes. So we should cover the research news and science news around the globe. Okay. Today I came with you a very interesting story that accelerating waves shed light on major problem in physics. You know the accelerating or expanding universe, that the universe is actually expanding like this. This is the Big Bang. Okay, let me draw it with more clearly. Okay, so this is Big Bang. Okay, and we know how the universe is accelerating like this. Okay, this is the arrow of time. Similarly, there are accelerating waves. Okay, we will dive into deeper what does this actually mean. So in summary, what it says, researchers at Tampere University and University of Eastern Finland have reached a milestone in a study where they derived a new kind of wave equation. So it is actually a new discovery. They have devised a new kind of wave equation which applies for accelerating waves. The novel formalism has turned out to be an unexpectedly fertile ground for examining wave mechanics. So, if you are interested in wave mechanics, you can get this new kind of wave equation and do research on this. Okay, I will show you the new kind of wave equation a little bit later. Okay. And this wave equation miraculously has connections between accelerating waves, general theory of relativity, as well as the arrow of time. This is very interesting fact that this new discovered wave equation has relation with general theory of relativity. So it's a topic we need to notice. Okay. So what does this theory says? Whenever light interacts with matter, light appears to slow down. We all know that whenever light interacts with matter, such that this is a matter, okay, matter or some glass or slab. So whenever light comes down and it will go under this, we know light will slow down, and there is a very interesting formula for this, that c dash equals to c by mu. So this c dash is the new speed of light in that medium, and it basically slows down, and mu is the reflective index of that medium. Okay, this is not a new observation. We all know that light slowing down is not a new observation. and standard wave mechanics can describe most of these phenomena. Okay. For example, when light is incident on an interface, the standard wave equation is satisfied on both sides. So, what it's saying that whenever light is falling, suppose this is a media, this is N1, this is N2, two type of media. Okay, light when is falling in that interface and it is coming like this. Okay, I can draw a straight line in that. So for this portion you can derive wave equation, for this portion you can derive another wave equation, and what is saying that we apply boundary condition to link the two sides together, and there is this portion. Okay, so to solve this portion we did in our electromagnetism classes that we solve this wave, and for this portion we use the boundary condition to make it a continuous wave. Okay. However, at the boundary, the incident light must experience an acceleration. This is the new discover or the new formula which you have not heard of. What is saying that in that encounter, this portion where we introduce the boundary condition, the light or the wave experience an acceleration. This is a very interesting. Okay, so if you want to do research on wave mechanics, then keep in mind to take the wave equation, which I will show you a little bit later, and this boundary condition the wave actually feels accelerated. Okay, so far this has not been accounted for. Okay, so this is the mechanics of the new discovery. Okay, so there are, why I am covering this, because it has many implications in our world. Okay, one is no hope for a time machine. What does it says that in a breakthrough result, or when this new equation was discovered, the researchers showed that in terms of accelerating waves, there is a well-defined direction of time, a so-called arrow of time. This is because accelerating wave equation allows solutions where time flows forward but never backward. So whenever, suppose this is the new wave equation, when I am solving this, I am getting a time which runs only forward and not backward. Okay, so this actually saying that we cannot go in the past according to this equation. Okay, this is not that you cannot go past in any day. In far future you can introduce a new theory which can actually say that actually you can go past, but this new wave equation when we are solving, we are seeing that in this wave equation time is actually running forward. So this is a very interesting result, that it's saying that our universe actually satisfying only forward direction of time. Another application is that relativity trumps over the controversy. What it's saying that, okay, there is a famous debate in physics which is called Abraham-Minkowski controversy. The controversy is that when light enters a medium, this is a medium, okay, it is glass, water, any kind. So suppose it is light coming and it is entering in this medium. What happens to its momentum? Suppose it has momentum p1, it has momentum p2 in that medium. So what will happen to p2? Is it equal to p1 or not equal to p1? If not equal to p1, then what it will be? Minkowski said the momentum increases. Okay, Minkowski told that the momentum will increase. while Abraham insists that it decreases. Okay, but in this new theory, which I am right now saying to you, what we have seen, Koivurova, the scientist who revised this theory, is saying that in the point of view of the wave, nothing happens to its momentum. In other words, the momentum of the wave is conserved. That means P1 equals to P2. But remember, it is the point of view of the wave, অর্থাৎ in reference frame of the wave. Okay, the momentum remains conserved, but wave experience a time that is different from the laboratory time. But in our reference frame, we see that the wave experiencing a time which is different from our laboratory frame. The researchers found that accelerating waves also experience time dilation and length contraction. This is actually from our point of view. Okay, so from our point of view or laboratory frame, we are seeing that new accelerating wave has is experiencing the effect of time dilation and length contraction, which is again proving Einstein's special theory of relativity. Okay, and there are another exotic application which I need not cover this. Okay, so what is the wave equation? I have told you the new discover what is actually saying and its application. Okay, but the question is that what is the wave equation? Let's go into this. This is the paper. Okay, you can see time varying media, relativity, and the arrow of time. It is the headline of that research paper. It is written by Matthias Koivurova, Charles W. Robson, and Marco Ornigotti. Okay, and equation number 5. I am zooming this. You can see this is the new discovered wave equation, which is the accelerating wave. You can take this wave equation in your research paper and do research and show the world. Okay, so